Today we'll learn how to design YouTube. So you have seen, other previous videos for designing other system, and you are very familiar with, many of the non-functional requirements, and we're going to talk about that also. But it's still, there are many things we can learn here. That's some new technology. So this is the YouTube designing. This is also uh, there will be similarity also with the Netflix app also. So both will be similar. So let's concentrate on the YouTube. So for that, let's write some of the functional requirement here. FR, and then functional requirement YouTube. What we do, the main thing is upload video. That's one of the main thing. Then view video. That can be for the paid user. There can be download video also. There is a like, comment, all things you can do here, like, comment. But the most of thing is this upload video and the view video. So this is our functional requirement. Let's see non-functional requirement also. So NFR. So in a non-functional requirement here, I want to say first one is reliability. Let's do reliability. So reliability here, like no video should corrupt. So that is the reliability. No video should corrupt. Every day, a lot of users upload the video, and the reliability makes sure the no uploaded video is in corrupted state. So that's where we need reliability. Another one, scalability. So a lot when we upload spelling scalability. Uh, okay, so scalability. So when we upload the videos, a lot of videos, there are the multiple process in a background running, and that should be responsible for handling those requests. And if there are many requests come at the same time, then one server cannot handle that. So for that, we need the multiple servers, and that's why we need the scalable. So that's we call the horizontal scaling. If you do the AWS cloud or Google Cloud, anywhere we have those functionality. So when the load, there will be some number fixed over there, or when the load is more, system will be scalable automatically. Another one we can say availability or available. So system should be available, it should not be down, otherwise a lot of user will go to the different app. So that's why system should be always available. Another non-functional requirement can be consistency. Consistency can be eventual consistent, strong consistent. So it's okay, like if you get newly uploaded video 2 seconds delay, but we cannot compromise with availability. System should always be available. But when you say upload the videos and in another part of the world, the video may appear in a 2 seconds or later 4 seconds later, that's fine. Those kind of things. But when we compare between this availability and consistency, we have to give more priority on availability. But we need to take care of consistency also. It should not, we have to make sure should not take a lot of time to be visible in some other place. So that's also we can say reduce latency. So network latency, that is non-functional requirement. Let's do, based on these things, now let's collect some facts, and then we start designing this. So facts. So facts is, there are 2 billion users, 2 billion YouTube users. That's the facts. And out of the 2 billion users, we can just assume some number, but it's a intelligent case is, 5 million active users. So 5 million active users, they upload, the video on daily basis. So if there are 500 million active users, and just consider if they upload one video per day, then you can say 500 million uploads every day, right? So that's the one of the fact. So let's consider 500 million upload every day. And when we make the video, usually, like if you make a video, new video, create new video, or upload, just consider average, just good number for the calculation, maybe the 500 MB. So 5 million into 500 MB of the record is uploaded daily. So in this way, if you calculate those things, then you can say 25 to 50 petabyte of data each day we upload. Every users upload each day 25 petabyte of the data. And again, if you uh, come to the seconds, like just we want to know in each second how many uh, videos are getting uploaded, what is the size of that, then just to 50 petabyte divide by 24 divide by 60, so hour, minute, and then again divide by second. So if I do that, then still if you calculate, then we'll get 2 terabyte 2 terabyte of data per second we upload, and system should handle like 2 terabyte of data per second. So that's the fact. So so in this way, you know yeah, this is the fact, and we'll add few things more later, but let's start designing our system based on these data. So the first of all, in one side we'll have user. So user can be, the user can be iPad. So from the iPad, we can upload the video, or mobile, or computer. So that's all things. I can put that in a user. So I'll bring this guy here. That's the user, and that's the user is going to upload the video. Okay, so this users, we know the 2 billion users, 500 million active users. So there are 500 million active users. They upload at the same time. There will be multiple servers that they are dealing with all these requests. So that's why we need the load balancer. So let me put that one load balancer here. Load balancer. Okay, so through the load balancer, and all all upload comes to the load balancer, and the load balancer will choose one of the server to handle these videos. And there can be many servers here. So I can say this is video upload service. So I'm just showing one of these, but this can be multiple. I don't know, 1,000 or 2,000. This kind of server, they are running all parallelly in a distributed way. And when request comes to the load balancer will see, okay, this server is busy. Okay, send to another server, then send third server, fourth server, whoever is available. And if load is If load is more and there is not available server, then there will be horizontal scaling, and the new server will be added in this structure. So this one, just I'm showing this, but just understand that there are multiple service for this video upload. Okay, from this video upload service, then I can say this system will take care of this videos, and this is going to be stored somewhere. So of course we are not going to store that in a database, but we'll store the metadata in a database, but we store this in a S3 bucket somewhere. So just I'm going to represent this S3 bucket. That's in that's a blob storage. So here in AWS there is S3, we call the S3 bucket. Okay, so S3 bucket, and also we need to store all the metadata for the 500 million users. Like metadata is like name of this video what we uploaded. So that's thing, uploaded date, and who is the user. Maybe you can have some user ID, and those kind of data we need to store in a database. So we can have the MySQL or NoSQL, so that's depend on us. But whenever there is a lot of data and we need high performance, then usually it's a good idea to choose NoSQL, because there is a horizontal scaling, and also there is not constraints on this uh, NoSQL, like a Cassandra I can see here, and that's why the performance is very fast. So let me add one more box. Okay, so we can store this in I can just say it's a NoSQL, and choice is yours. You can use Cassandra or any other. Okay, so this is very much the similar in other system design, uh, but we'll see some of the unique things here. So what happened when user upload the video to this video upload service, then the video is let's say 400 or 500 MB, and that need to be displayed in again displayed in a user. So that is in an iPad, or sometime in a very big TV, or your mobile phone or laptop. So we need the different kind of resolutions. So that's where we need to encode that data, and we need to make different different resolutions of the video. Like one video is good for mobile, one video good for the big TV, or one good video good for different kind of a screen. So those kind of things in a background, YouTube or the Netflix, they take the original video, and in the background they process and it make it different format of the video, so that all the users can be satisfied. So for that, the way usually, and that's the new things we are going to learn. So as soon as we upload the video here, there are multiple servers, and all the multiple servers is going to put that data in a somewhere in a queue system. And here in for us, we can just say that's a Kafka here. So I'm just going to put that in a Kafka. So all servers, multiple servers, put that data in a Kafka. Again, that's all the data will be in a Kafka queue. And from there, there will be another service that you can say encoding service, and that's the queue. And there can be again many encoding service that's running in a parallel. I can just say that's a encoding service. So encoding service running in a parallel, and they gets the information about uh, this data. So maybe we have already stored in S3 bucket. So in a Kafka, we can put the metadata, like okay, where is the location of this file, and then that's just put that, and there will be the millions of the record. coming here, and and that's in a queue. So there will be multiple encoding service that keep taking the data from the Kafka and start encoding and change to the different format. Different format, you can just say, uh, like some MPEG format. So just let me add some more detail here. Like that will convert to MPEG format, and that should be in a different resolution, maybe 180 pixel or 1440 pixel or many other. That can satisfy different kind of the screen resolution. So let's create those video, and after creating the videos, the new videos should be again uploaded to S3 bucket. So the second, bring it here. So one line I can draw from to this place. So that will be uploaded here. And again, this information, again, that information also uploaded to this uh, database also. So let me bring here and one point that goes to this place. So that metadata also information will be stored in a NoSQL. So that's a good. And other thing we need to understand, when this encoded video is available to the user can view that. So again, in this case, we need the different servers near to the users. Like the one user is in India, other user in USA. So user in the India get data from USA, that takes time. So that's why we need to have some CDN concept, content delivery network, where we put all this video data in the CDN server in a different locations. So for that we need CDN. So let me cloud computer. Okay, just I want to show this CDN server, this image, and this encoding service will put that in a CDN service. So just let me draw one line, or I can draw from here. Yes, so you can put that, and the CDN server will be again in a different region based on the demand. One server will be, many servers will be in the India, many servers in the USA and different country. And AWS has done good job in these things, like maintaining the CDN in a different places. Here in this case, YouTube use a lot of CDN. Okay, so that's the good thing. So once the data is available in a CDN, the next thing is how these actors get this data from here. So this is a maybe the 40 MB, 50 MB, because when we convert to the MPEG, the, the size will be lower, small size. So, and for the different resolutions. So when the iPad user use, they will get that's iPad version of resolutions of the video. So in this case, how to get this video? So here, if you have seen, like when you watch the video in a YouTube, you see some bar going on below, and the bar just keep on increasing. That's keep buffering the data. So that means that's there is a different technology here to get the data. Like this user will not download whole video to in order to view that. So that's called the streaming. So they just get chunk of the data from CDN, and that's we call the streaming. So let me draw one more line. I will start from here, CDN, and this goes back to this user. Okay, and this one I can say, just to understand, this line is, this is called streaming. So in this technique, streaming technique, using this streaming, the chunks of very small chunk of data go to the actor or the users. But sometimes when you need to download that, then of course whole video will be downloaded. But for the viewing, we need the faster response. So for the viewing, we need to we should not download complete video. Otherwise, there will be a lot of latency. So that's the about this thing about the YouTube design. Now the next thing is, calculate we can calculate how many servers we need. Like, let's say, yeah, so in order to calculate like how many servers we needed, we need to know that figure. And maybe there can be the different tool to understand that. We can also estimate based on this data, and we can calculate. But there is a tool, there are different tool. One is the New Relic. So that New Relic, when you add the New Relic, that is, that can also show the throughput of the particular servers. In that we can test like how when we have many load comes to this any service that goes to the New Relic, another third party uh, app. And in that UI you can see, okay, there are many error coming. And in that way we can find, okay, what is the average number of requests handled by one server. And in that way uh, we can estimate, okay, how many servers needed. And that, yeah, that estimation is, even though there is a horizontal scaling, but that estimation is needed to calculate the cost. So that's all for now. Thank you.